What is mass? You may have learnt in school that it is the amount of matter something is made up of. But in truth, this is just the tip of the iceberg. If you know introductory modern physics, you know that some particles have mass and some particles don't. For example, photons. Now why is that? Moreover, what mass really is? To understand this, we need to understand the fundamental nature of our amazing universe. So without any further ado, let's begin our video.
In today's video, we will try to understand mass. Unfortunately, there is no proper definition of mass, so we will explore its diverse explanations to understand its ambiguity. We can divide mass into two types, inertial mass and gravitational mass. Mass has a tendency to contradict motion. You may remember the first law of motion, which states that a body tends to stay in its original state of motion. This is inertial mass. When you jump, you eventually come down due to almighty gravity. Gravity exists because you have mass, no matter how much. Thus, this mass is called gravitational mass. If you are confused, don't be. Einstein was confused too, and he took them both to be the same in his theory of general relativity. According to it, our universe is a fabric of space and time. Anything with a mass forms a curvature on it, just like a bowling ball on a stretched sheet. Now this curvature is funnel shaped and affects the other objects within its range. The effect is also known as gravity. Hence we could say, mass is the charge of gravitational interaction, and without it, no gravitational force exists. With all this, we still just have understood the tip of the iceberg. So let's dive into special relativity and start with mass-energy equivalence.
E is equal to mc squared. We all know this equation, this famous equation of Einstein. But what does this mean? Here E is the net energy of any system, m is the mass of the system, and c is the speed of light. It simply means that energy and mass are in fact the same and can be converted into one another. Earlier in this video, it was said that photons are massless particles at rest, but they do have energy. So if we take a box of 1 kg and an imaginary box of photons with an energy equivalent to 1 kg, they will create both the same curvature in the fabric of space and time. That is, they will both create an effect of gravity. Thus, we can also define mass as a property of energy.
Let's take an example of a proton, the positively charged nucleon. A proton is made up of three particles called quarks. We won't dive into their types right now, that's for another video. Now the combined mass of the quarks is a fraction of the total mass of the proton. So where does the extra mass come from? It comes from the energy that glues the quarks together so that our universe can exist. Now you might ask, why does the quarks have mass? To understand this, we need to understand the God particle, the Higgs boson. In simple terms, the Higgs boson is a particle that gives mass to other particles. It creates a Higgs field, and the particles which interact with it have mass, and which do not interact with it do not have mass. The more a particle interacts, the more mass it has. With all this research, we still do not have a solid definition of mass. It's funny how such a fundamental concept is so complex. Our cosmos is really full of surprises. On this note, let's end our video. Please hit the subscribe button if you want more content like this. Thanks for watching.